Hello, everybody. My name is Houssein Djirdeh, and I'm a web developer advocate here at Google.
Hi, everyone. My name is Shubhie Panicker. I'm a software engineer working on the web platform in Chrome.
In our talk today, we'll cover how we at Chrome have been advancing the web framework ecosystem in a number of different ways. Engineers, managers, advocates, and everybody on the Chrome team share a very common goal. And that is answering the question of how we can collectively make the web better. Now, there's a number of different ways that we try and make this possible. We continue to improve the core JavaScript and WebAssembly engine that powers Chrome. We also continue to improve the API surface provided by the browser so that developers are better equipped with APIs that they can use to improve how their sites function and load. And at another angle, we also try to improve websites that are already in production today. But things get a little tricky here. How exactly should we do this? For the most part, we can probably agree that most web developers do not build entirely custom infrastructure and tooling. Where possible, developers would usually prefer to rely on open source tools. So one way to improve actual websites that developers ship are to improve the actual tools that are being used to build those sites. Better open source tooling can directly result in a better web. But what exactly do we mean by open source tooling? Well, when it comes to building a brand new site from scratch, developers today have many options. Client-side frameworks can be used to build dynamic and fully fledged single-page apps. Static site generators are tools many people use to build static sites and applications. People also have the option to use a content management system. And there are also website builders like Wix and Squarespace. For the purpose of this talk, we want to focus on one of these categories specifically, namely client-side frameworks and UI libraries. MDN will soon release the first edition of their developer and designer survey to try and learn more about the needs and frustrations of web developers. With over 28,000 responses, one interesting result from this survey was that 72% of respondents actively use React, Angular, or Vue for their sites. We also tried to look at this data from a slightly different angle and find out how many sites that use frameworks make up the top 100 URLs by time spent. And we found that 30 of the top 100 URLs use React, Angular, or Vue. And this does not take into account many other frameworks that are available. We also wanted to get an idea of how many actual sites in the wild use a tool like React. By using HTTP Archive, we found that over 350,000 origins use React in some form. All this data shows that frameworks are used in a lot of sites. So it's not really just about advancing the ecosystem itself, but by doing that, we would ultimately be advancing the web as a whole.
So we've identified our target audience, but how can we help? Most concerns here fall into two broad categories: user experience and developer experience. So that's UX and DX. Most of our talk today is going to be focused on user experience and performance. This is an important problem. Frameworks are struggling to meet Chrome's targets for user-centric metrics like first contentful paint, largest contentful paint, first input delay. Paul and Elizabeth's talk covered what these metrics mean. Our tooling emphasizes the initial page a lot, and this is challenging for these apps. On the other hand, they do well on route transition, subsequent interactions, but our metrics don't reflect this yet. So how should we invest in the framework ecosystem to address both DX and UX challenges? We think there's a big opportunity here for tooling to help with both of these problems, in particular by bringing good defaults and by being opinionated. So I want to take a moment here to define this notion of what we decided to call a web framework. It's an end-to-end system that controls every aspect from getting started, everyday development, through deployment. It's directly positioned to impact both UX and DX by controlling the server and the client, the build and the serve, the dev and the prod environments. And this is a core premise of our work in this space. Through these web frameworks, we want to enable developers to successfully build and maintain high-quality production apps. So a web framework helps a developer to be productive. Building a production app just requires too many different moving parts that the developer has to reason about and string together. This list is just a small subset of the concerns of a production app. And if you're thinking that, I want to minimize opinions and integration so I can maximize my flexibility, consider embedding yourself in a team of developers who are on the hook for shipping a business-critical app. Developers want to and should focus on features. And I know this from my personal experience working at Google, being on the hook on infra teams for shipping products like Google Search, Google Photos. In addition to developer productivity, web frameworks are also directly positioned to impact performance and UX. And this is because they bring opinions on things like server-side rendering, flushing early HTML chunks, streaming. They control how and when exactly to fetch JavaScript, CSS, data, and images. They unlock features like progressive delivery, lazy fetching. All of this directly impacts those user-centric performance metrics. So I want to take a moment here to clarify the distinction between, on the left, a UI framework or library versus what I just defined as a web framework. UI libraries like React and Vue, they tend to be agnostic to a lot of the concerns I mentioned before. On the right, we have fuller featured web frameworks in the ecosystem, like Next, Nuxt, Gatsby. Angular and Ember kind of blur the line here by playing both roles. So if you're starting to build a new app, I recommend reaching for a full-featured web framework so that developers on your team can focus on what matters most to them, which is building features. Starting with a bare-bones UI framework means reinventing the wheel and building a lot of your own infra. So we're excited for all the strides being made by web frameworks and UI frameworks in this space. These are all the accomplishments from various frameworks: Angular, Vue, Svelte, Ember, Gatsby, and Preact. We're in close contact with the Angular team and really excited for their achievements on both UX and DX. In particular, they ship differential loading, which reduces polyfill in modern browsers. And they have automatic deployments to different platforms, to name a couple of things. Also, Dion mentioned in the keynote that we have funded a number of projects with the Framework Fund. We'll have funding again next year. So if you're playing a role in the framework ecosystem, providing something of value, please apply for funding. This is just another way to scale beyond our own small team by helping other teams. At Google I/O, I mentioned that we kicked off an effort in this space, directly collaborating with Next.js. In particular, we are starting with performance improvements first, both because this is an important problem needing attention, but also it wasn't overlapping with other efforts. So hopefully, at this point, the choice of React might be clear. Like, it has a huge developer mindshare. It's heavily used in apps where Chrome and web users are spending their time. And we found Next.js was the most production-ready web framework for building a general-purpose React app. Plus, we're a small team, so we had to start somewhere. And finally, we are definitely counting on and working towards having ripple effects and inspired copying in other parts of the web frameworks, like Gatsby, Nuxt, Angular, Ember, etc. So this investment in the framework ecosystem is an additional space that we missed. This helps bring the web platform work to a lot more developers. And we've realized as an organization that our efforts are better spent collaborating and contributing to the framework ecosystem instead of competing and pushing our own frameworks. And it is in this spirit that we are contributing to Next.js instead of building our own thing from scratch. So I mentioned that we'll have a performance focus, both for our work and this talk. So which problems should we address specifically? To understand what's going on and why our perf targets are not being met for these user-centric metrics, we did deep tracing on 25 Next and React apps. And I want to share some insights as it directly informs the projects that we are undertaking in this space. By far, the big issue that stands out in traces is this delay in servicing the first user interaction. And this is typically from fetching lots of JavaScript, so that's all the network from HTTP to in yellow on the left, and then executing all of that code on the main thread, and that's in pink. And as you can see, that long execution on the main thread is blocking the user's interaction. So in this case, it's taking a couple of seconds on the network and another 2 to 3 seconds on the main thread. This is a long window during which the user is unable to interact. This is one reason why a lot of our efforts have been focused on JavaScript. First interaction isn't the only problem. We're also seeing slow times for first contentful paint, largest contentful paint. And there's a number of reasons for this. For example, the time to first byte is slow and takes over a second. We're often seeing sync scripts in head that are render blocking, including third-party scripts that tend to sneak in here. Web fonts are slow, hero images are slow, and sometimes not optimized. And finally, the third problem I want to mention is the problem of data. Data is as important as JavaScript for rendering content, getting the page hydrated. And we are seeing a lot of fetching raw data from REST endpoints, a lot of post-processing of the results. And this is a lot of JavaScript work on the client, in addition to all the code that's needed to execute this. And finally, there is this waterfall from cascading fetches of JavaScript and data. So I'm going to hand off to Houssein to talk about what we are doing about all of this in Next.js.
So one thing we've been doing the past 6 months has been working closely with the Next.js team to improve the framework in a number of different ways. And we've approached this by identifying areas of improvement along with the team and slowly incrementing and adding optimizations one after the other. And this was a team effort. There were quite a few of us involved that worked alongside many amazing folks in the Next.js team that made it possible to see a lot of these features land. For things that we worked on, we tried to find the lowest hanging fruit that will result in the biggest impact. This included improving the Webpack chunking strategy used in Next.js, differential loading to minimize the amount of polyfilled code shipped to browsers that don't need it, a number of JavaScript optimizations, improved performance tracking by instrumenting a few custom metrics, and we're also exploring a conformance story to see if we can generate better errors and warnings for common developer footnotes. To begin, let's start talking about what we've been doing to improve how chunks get generated in every Next.js application. We began by leveraging Webpack's split chunks plugin to modify how a Next.js app gets chunked and outputted to the browser. We did this by making sure a separate chunk is outputted for every third-party dependency of a certain size. All framework-specific libraries, like React and React DOM, are outputted in their own fixed cacheable chunk. And the rest of the application code is outputted in multiple small shared chunks that minimize duplicate code across routes. The main purpose of this new strategy is specifically to limit code shipped to the browser to only what is actually needed for the route itself. We tried our new chunking strategy with a few major Next.js sites, one of them being Barnabys.com, a large search engine for antiques and collectibles. Almost immediately, we saw some amazing wins with granular chunking enabled. And here you can see a side-by-side of the same site with and without the feature enabled. The biggest wins were noticed after navigating to multiple routes throughout the entire application. You can see that after navigating through 6 pages, the difference in the amount of JavaScript code fetched was substantial. Over 100 kilobytes of duplicate code was shaved using a better and more nuanced chunking strategy. With Barnabys.com, a 23% app size reduction was noticed, with much faster navigations and improved caching. And if we take a look at things in terms of the largest bundle, the biggest JavaScript chunk alone was cut down in size by 30%. SumUp, another major Next.js site that we tested our chunking strategy on, saw a reduction in their largest JavaScript bundle by 64%. And again, the amazing thing about these changes is that it involved no actual change to the user's code whatsoever. This was all by just turning a flag on that changed the chunking strategy to use our newer granular approach. Now, differential loading was another optimization that we worked on. And the idea behind differential loading is to serve modern JavaScript to modern browsers, which is often 80 to 90% of traffic. To do this, we leverage the fact that modern browsers recognize and load script tags with type module, and ignore scripts with a no module attribute. Older browsers don't recognize these attributes, so they load the more aggressively transpiled and polyfilled no module scripts. By just applying this simple technique, we saw a 7% reduction in the total JavaScript for Barnabys and other sites. And that number jumps to 15% when you look at only first-party JavaScript. There is a potential here to reduce the size of your JavaScript by up to 20% with no change to your code. So shipping modern code has some great performance benefits. However, we wanted to find ways to optimize this modern code even further. And to do this, we've been working with the Babel team to improve support for transpiling modern JavaScript. Many of us have used Babel to transpile modern code so that it works well in all browsers. More recently, it's become common to use Babel preset env to target modern browsers. And we do this by transpiling code so that it runs in all browsers that support script type module, since that gives us a nice way to serve the code to those browsers. Today, we're excited to introduce a new Babel preset that optimizes specifically for this case. It's called Babel Preset Modules, and it's available on NPM right now. Let me show you how it actually works. Let's say we have this simple function written in modern JavaScript. Compiling this for modern browsers using preset env's target ES modules outputs a fair bit of code. But running the same code through preset modules produces this. It's a lot smaller. Here's the thing. Both outputs run in all browsers that support script type module. And this works because instead of converting modern syntax to older syntax to avoid browser bugs, the preset fixes each specific bug by transforming to the closest possible non-broken modern syntax. In our example, only one browser bug affects our code, and this equivalent syntax circumvents it. The result is that modern code can be delivered nearly unmodified to most of your users. If you're developing for modern browsers or using the module no module approach, we're interested in hearing how Babel preset modules can work for you. We're also going to be working on incorporating these optimizations back into preset env, bringing the benefits to even more developers. Another thing that we did was try and improve how we track performance in a framework like Next.js. And we did this by leveraging the user timing API to add marks and measures for key points in the application lifecycle. This includes the time it takes for hydration to begin after loading a page, and the time it takes for hydration to complete, and the time it takes for rendering to start once you make a route change, and similarly, how long it takes for a page to finish rendering after navigating to it. By applying what we thought were some of the most important performance metrics that should be tracked in a web framework like Next.js, we wanted to make sure developers don't have to worry about trying to measure these nitty-gritty metrics themselves. And the amazing thing with leveraging the user timing API is that all these values will now automatically show every single time you test a Next.js page with Lighthouse. One other thing that we're currently exploring is a conformance story so that better errors and warnings can be surfaced to the developer for many common footguns they may run into. Earlier in this talk, Shubhie covered how there are many things that developers need to be wary of that could affect the performance of their site, such as blocking scripts, web fonts, unoptimized images, and so forth. Now, all these things are just some of the many common problems that developers have to deal with when building web pages. At Google, we began adopting a conformance model for many of the internally built web frameworks that we use to build many of our products. And the idea behind this conformance model is that it doesn't just statically analyze code, but actually tests for multiple checks after code has been compiled. By doing so, we're able to catch a lot of potential issues with our final output that we may not have noticed until it's too late. This feature has helped teams build large, scalable apps while ensuring that code remains in check as much as possible. And we wanted to see if the same sort of concept can be applied to an open source framework like Next.js. For example, what if you ran a Next.js build, and then you see an error telling you that you've included a render blocking script, preventing you from actually submitting your changes? Now, this concept builds on top of the idea of regular build warnings and errors by providing checks that are a lot more precise. It needs to be enforced, but we also want developers to have the flexibility to decide what to enforce within their team. And we want to do this by providing some API control for them to enable and disable certain checks. This entire concept is still very early stages, and there's a lot that we need to think about. But we have an open RFC, and we would love to hear any feedback that you may have.
So going back to our slide from before, and looking at this problem of this large chunk of JavaScript blocking interaction, we found that even after all of these optimizations, we are still seeing 200 and 900K compressed JavaScript, and this still means multiple seconds on the network and the main thread. So the most obvious thing that might come to mind is, ship less JavaScript. But this means shipping fewer features. So again, consider putting yourself in the shoes of a team responsible for a business-critical app. It's not practical for them to drop all their JavaScript beyond the first 100 or 200 kilobytes and just remove all ads, tag managers, and analytics, and so forth. The point stands, though, that features come at a cost, and JavaScript is particularly expensive on the main thread. And so we need to fundamentally uncouple this trade-off between features and performance. So in Next.js, we are already doing all of these things: compression, minification, tree shaking, dead code elimination. And then Houssein mentioned the additional optimizations we had around polyfills, optimized chunking. So even after tackling a lot of this low-hanging fruit, we are still finding that JavaScript is too expensive. So this is a DevTools timeline on a Next.js app, and it shows us what's going on in the initial page load. There is this big, long task from setup and hydration, and that first user interaction is still blocked until the script has finished. So you may have heard of concurrent mode in React. It enables progressive hydration by breaking up that long, continuous task that involves setup and hydration into lots of smaller tasks. It's not that it's eliminating hydration, it's that it's breaking it up and staggering it. And the idea here is now the main thread is serviceable, it can respond to user interaction. So we did some work to enable concurrent mode in Site, so let's look at the results from that. The blocking time reduced a lot, by 53%. But why isn't it 100% better? So to understand that, we're going to go back to that original trace and see what's going on here. So on the left, we are basically seeing about 1/3 or half of the slice. On the left is all this kind of Webpack bookkeeping, module initialization, and setup. And on the right, we have React coming in, doing DOM work, and doing hydration. Now, the problem is that both of these depend on what happens to be on that page, so it can vary arbitrarily. These are two very different opportunities. Turning on concurrent mode immediately fixes the problem on the right. But we haven't done anything about the problem on the left. So we're actually just starting to tackle this by looking at deferring module initialization and setup. And the idea here is that we want to get to getting that startup time to be fixed or constant and decoupled from the specific contents or the size of the page. So once we tackle that, we'll achieve our fixed startup, but there's still a missing piece here. We still need to be able to prioritize the specific features on the page that the user actively interacts with or engages with. And this is where selective hydration comes in. This was announced at the recent ReactConf. And the idea here is as the user interacts with the image carousel or the left bar or any of those components or the top, those specific items are prioritized over everything else in the page. So finally, I don't want to leave you with the impression that turning on concurrent mode was as easy as flipping a switch. This involved pretty substantial changes to Next.js to update incompatible concepts. It required migration of the target app. There's still the problem of third-party NPM deps that need to be upgraded. And even though this is a bunch of work, we are on course to update the Zeit app to concurrent mode. And this is the first big step towards uncoupling that fundamental trade-off between features and performance. And we are already seeing a 53% improvement in that first interactive blocking time. So there's a lot more beyond performance in terms of having a compelling web framework that makes developers productive. And at this point, I want to welcome our guest, Tim Neutkens. He's the lead developer of Next.js, to talk about how Next.js helps developers here.
Good morning, everyone. So Next solves two things in the React ecosystem. It helps you with going to production really fast, but also with developer experience. So let's dive in what Next actually helps you with. So it's easy to get started with Next, but also it's easy to evolve to larger applications. So we want to ensure that your app is actually, or site is becoming bigger and more successful over time, and that your team can actually get great developer experience in doing so. Which leads to the next point. It is great for individuals, but also for teams. And you can actually do static site generation or dynamic rendering per page, so you can choose what you want to do per page as your project grows. So in short, Next is great for really simple websites, but also for the most demanding apps, like the largest websites in the world, for example. So let's look at what Next helps you with currently. Or, as Shubhie said before in this talk, it was basically, there's a lot of things that you have to think about when you're working on a developer, when you're developing a website or a web app. It goes from like backend logic to unit testing, UI component models, and everything really. So Next helps you with a subset of these things today, which is the backend logic and server logic. So it actually helps you with data fetching, but also with writing API routes if you want to. Then there is the UI component model. Next obviously uses React, as we said. And it helps you just write React components and not worry about all the other things. Then there is data flow. And data flow means data fetching, but also, for example, like how you get data into your app. Then there is CSS encapsulation, which means how you write CSS in a way that you don't have to go back and rewrite everything later on, as you get encapsulation per component, for example. So Next ships with Start.jsx, which is this library that we wrote that we think is really great for writing encapsulated CSS, but also we allow you to integrate with any CSS and JS library that you would want to use. So that's like styled components or emotion, for example. Then there is deployment and releases. So Next has a build command that outputs a production-ready web application for you. So you only give it React components, and then we build it for you in a way that actually is going to work in production. And we optimize a lot of different things in that way. And when it comes to hosting Next.js, the company behind Next.js, Zeit, the company I work for, offers a hosting platform that is specifically tailored to Next.js apps. So it optimizes a lot of things, comes with a CDN and that kind of thing. Then there is security. So security is a really broad topic, of course, but Next specifically helps you with enabling CSP in your app by default, for example. It also, through React, helps you prevent XSS injection and other things. As you can see, however, currently there are a few things that Next doesn't cover. And those are the things that you actually have to think about yourself and like investigate and figure out what you're going to do there. And generally, companies end up writing their own solutions for this or implementing their own solution. However, to give great developer experience, we want to help you in being better at this. So let's have a look at what is currently being investigated to improve DX for you. So these are the things that we're currently working on to help you with building more scalable web applications. So one of them is translation. So we're seeing a growth in websites that are using a non-English, that's targeting non-English speakers, for example. So that means that there need to be good internationalization solutions out there, because otherwise it gets really hard for teams to implement this. And they might actually choose to not implement it at all. Then there's unit testing. So unit testing, integration testing is a really broad topic also. But we're aiming to provide good defaults for you to help you not have to set up all the compilation and bundling involvements that are needed to do unit testing and integration testing for React, for example. There's image handling. So images make up a large percentage of what you show on a website, right? But we don't provide an opinionated way to load images currently. So that means that it's really easy to include images that are too large or too small or something that is just not optimized enough. So we're working on that also. There's analytics. And analytics is something that you all probably use in a website at least, because you want to know what your users are doing on a page. However, to correctly implement and relay analytics in single-page applications is really hard. You need to be very aware of like which route changes are happening and that kind of thing. So we're starting to investigate solutions that will help you with this also. Then there's error reporting. So you probably all have written bugs before, and it's really hard to catch bugs in production in websites, because it runs on a browser that is not your own browser, and because of that, you can't see what users are doing. So error reporting is very important in that way. So relaying errors that happen is going to be easier very soon too. And all of these improvements serve the goal of making you and your team more productive with good defaults that can scale. Another thing that I didn't mention in this slide, but we're also working on accessibility improvements that will help you report accessibility issues that help you solve them faster. And we're not doing this alone. As Shubhie and Houssein have been explaining, the Chrome team is helping us in this effort. So my team at Zeit, which is currently 4 people, including me, is working on Next more so from the developer experience side of things. The Chrome team is doing a lot of performance improvements. And besides that, we're obviously an open source project, so you can all contribute to improving the whole vision of Next. And there have been actually already many contributors, over 830, that have been involved in this project. So one of them that I would like to specifically call out is Giuseppe, who has been maintaining Style.jsx ever since it was released, as an open source contributor. And I'd like to hand it back to Shubhie now to end the talk.
Cool. I want to wrap up with saying that all of this work actually helps the web platform and web APIs as well, because working with these frameworks on pragmatic solutions for production apps actually tells us what APIs are missing, what APIs developers are struggling with. So this becomes a natural funnel of use cases back to the web platform. And so this is the end of our talk, and I just want to leave you with a few messages. If you're an app developer, please consider reaching for a fuller featured web framework instead of only thinking about the bare bones UI framework. This will enable your team to focus on features and be more productive. If you're a UI framework or a web developer, a web framework developer, please reach out and consider investing some time in a partnership with us. We really want your input on web platform APIs. Collaborations are two-way efforts, and we're really seeking to deepen our collaborations with Vue, Ember, Svelte, etc. And finally, all right, and anyway, finally, if you are in the tooling or the bundling space, like responsible for bundler, compiler, linter, again, please consider working with us closely. We want your feedback. And if it makes sense for your project, please consider applying for the framework fund. Thank you.